The next property that I want to talk about is the division property. And to do so, I've written a little example here that says in the numerator we have a fraction, and the denominator we have a fraction. And you probably remember from grade school, you'd see this sometimes if they gave you fractions, they'd ask you to simplify it with just numbers. They would complicate things by not just giving you a number over itself, which makes up a fraction within itself, and the numerator and the denominator. They would complicate things by giving you a fraction in the numerator and or a fraction in the denominator to try and confuse you. And so you'll probably see something like this on an exam, and you might, in the process of solving a real problem, it's very likely to come up, because when you're dealing with real-world problems that are described by equations, you don't know in the process of solving that equation what you're going to get. And sometimes it can get pretty messy where you actually would have a scenario like this where you had a fraction that the numerator itself has a fraction in it, and then the denominator might as well too. So it's a valid thing to consider. Now, the first step you would want to do in a situation like this is rewrite this in a form that's easier to work with. And the way you can do that is make use of the fact that in the numerator, 1 over x, we can write this in a different form where instead of having a fraction divided by another fraction, we can rewrite it as a multiplication problem that's easier to understand. And let me show you what I mean. I could rewrite this. The numerator would stay the same, 1 over x. I'm going to write it slightly differently because I'm going to rewrite it the whole thing, and I'll come back to what I'm doing and clear it up for us. So this 1 over x in the numerator is the same as this 1 over x. Nothing there has changed. Well, when you divide a number by a fraction, what actually happens is that fraction in the denominator actually gets flipped. And the 3, the numerator part of the denominator, stays in the denominator. But the denominator part, the x squared, gets flipped back up to the numerator of this new term I've written. And let me give an arithmetic example to clear this up. If I had the number 2, and I said that I'm dividing that by 1/3, what I would actually do instead is rewrite this as 2 over 1, and here the 1 is implied, so it would be like 2 over 1 there, times 3 over 1. And I know that's a little confusing, but I'm doing the same thing up here. Think of it this way. If you divide something by a number greater than 1, it gets smaller. 4 divided by 2 is only 2. But if you divide 4 by half, it gets bigger. Because what that really says is 4 over 1 times 2 over 1, which is 8. So if that statement helps clear this up, I know this is a little vague thing that I'm discussing here, so it might be confusing you. But think of it this way. Here's an easy way to remember this. Anytime you see a number being divided by something greater than 1, it's going to get smaller. Just like in the example I did here. 4 divided by 2 goes smaller to 2 because 2 is greater than 1. 4 divided by a half gets bigger because 1/2 is less than 1. And so it grows to 8. Because it's the same thing as saying you divide something by a half is the same thing as saying you're multiplying it times the inverse of half, which is 2. I'm going to say that again because I think that helps clear it up. Saying you divide something by a fraction, or a number less than 1, like 1/2, is the same thing as saying you're multiplying by the inverse of that fraction, which in this case would be 2 over 1, or 2. And so that's what we're using up here in our original example. All I've done is I've kept the numerator the same. The 1 over x divided by the 1 over x stays 1 over x. Nothing changes. But what I've done, instead of dividing by the original fraction, here, 3 over x squared, I have instead multiplied by its inverse. And the inverse is nothing but the original fraction flipped. The inverse of 3 over x squared is x squared over 3, just like the inverse of 1 over 2 is 2 over 1. So if that helps clear it up for you, makes it easier for you to follow this particular topic, just remember that anytime you're asked to divide something by a fraction, you are equally allowed to multiply by the inverse of that fraction and get the same result, and it'll be easier to work with. So just one last time, I know I've said this several times now, but I want to kind of help it sink in. One last time, all I've done is rewritten the 1 over x, nothing changed there. And I've decided that I would rather, instead of dividing by the fraction I was given, for the purposes of what I want to do, I know that I'm allowed equally as well to multiply by the inverse of that fraction in the denominator. Just the fraction in the denominator. Keep that clear in your mind. I'm only referring to the fraction in the denominator. And the inverse of 3 over x squared is x squared over 3. Well, now that I've done that, I can do like I did before, and I can make use of the multiplication property and end up with just x squared over 3x. And then from the original topic, I can look for a common factor, and I have one. X squared over x. X squared is nothing but x times x. So I can get rid of one of the x's. And if you have x squared and get rid of one of the x's, the exponent just goes to 1. So I end up with just x over 3. I know that was a very long description to arrive at this very simple result, but I wanted to make sure that this complicated topic is somewhat clear. We'll keep talking about it as we go along, but for now, just remember that if you're given a fraction divided by another fraction, it might be easier to work with it. First step, instead of dividing by that fraction, multiply by its inverse, which is what I chose to do. And it'll make it easier to clean things up and get to the final result.